Morning guys. So today we are going to study one more problem in inverse Z transform, right? X of Z given as Z plus 1 divided by 3Z square minus 4Z plus 1, and region of convergence have been given as modulus of Z greater than 1. Idana chodyam. So you have been asked to find x of n. Keep it in mind, this is Z domain, complex frequency domain, Z domain. This is in T domain, but of course it is in discrete shape, right? Discrete sequence and one. But whatever it is, this is in time domain, this is in complex frequency domain, right? So how to solve this? I mean, the reason why I am giving more emphasis or more importance about this particular point again and again. And the video like the reason is you will understand immediately when I start the next module. Okay, add the module start a complete grip this subject. Okay. So what I have to do? I have to write x of z by z is equal to z plus 1 3z square minus 4z plus 1 divided by z. Look, inverse z transform, which particular technique we are using? We are using partial fraction expansion, right? Partial fraction method use actually. About last problem actually video we are making this Z transform equation into ratio of polynomials. Extremely important point. Theory but is important. Okay, let me explain that one more time. This x of Z is a rational function. Okay, it's a rational function of Z that is, it's nothing but a ratio of polynomials in Z. Okay, so under this condition we can use partial fraction expansion to find x of n. Okay, so it is so this is a procedure x of z, or in case if they have given that particular question, try to convert this equation into ratio of polynomials, then apply partial fraction expansion. So what next? I have to use partial fractions, right? But how will you apply the partial fraction expansion? We have to first reshape this equation. We have to make this equation actually the law. A general form like x plus a, x minus a into x minus b. General form ratio of polynomials factors. Factors are to then only we can find the location of the poles as well as zeros, right? So this is one critical step actually before finding the inverse is a transform. So we have to just the partial fraction expansion same just added information. Why we are doing this? Because it exposes the location of the poles as well as zeros. This is very important information, added information. Max they might have missed it. Okay, so what I do now is z plus 1 3 z, I am just rewriting, okay, z minus 1 by 3 into z minus 1. Okay, from the question itself I can understand. I hope you are seeing this. I hope you are seeing this. I'm circling there. From the question itself we know that this particular actually polynomial function will have 3 roots actually. So here it is visible now because 3 factors are there, 1 2 3. Okay, So how to work அடுத்த step in the partial fraction. So let me write it like this: a1 by z plus b divided by z minus 1 by 3 plus c divided by z minus 1. Okay, so here a, b and c are constants. I am going to use the same old partial fraction expansion technique to find a, b and c. This particular step I am leaving it to you. Partial fractions doubt ചോദിക്കുന്നത് തെറ്റാണ് actually. Okay, so ഇന്നലെ തന്നെ ഒരു ഡൗട്ട് വന്നു, ലൈക്ക് അത് ബേസിക് ആയിട്ടുള്ള ഒരു നീഡാണല്ലോ. ഇത് കണ്ട ഇത് കാര്യമായിട്ടുള്ള പാർഷ്യൽ ഫ്രാക്ഷനും ഇല്ല. ഇതിൽ ഡൗട്ട് ചോദിക്കുന്നതിനെക്കാട്ടിലും നിങ്ങൾ തന്നെ അത് വർക്ക്ഔട്ട് ചെയ്ത് നോക്കുന്നതാണ് ബെറ്റർ. ബിക്കോസ് ഇത് ചെറിയ ചെറിയ കാര്യങ്ങളൊക്കെ എക്സ്പെക്ട് ചെയ്യുന്നത് ലൈക്ക് നാളെ നിങ്ങൾക്ക് എക്സാമ്പിൾ ബുദ്ധിമുട്ടായിട്ട് മാറും. ഓക്കെ, യു ഹാവ് ടു റെഫർ സം ബുക്സ് ആക്ച്വലി. ഓക്കെ, ബിക്കോസ് ബേസിക് തിങ്സ് ആണ്. ഓക്കെ, സോ ഇതൊക്കെ പ്രീ റിക്വയർമെന്റ്സ് എന്ന് പറയുള്ളൂ. പ്രീ റിക്വയർമെന്റ്സ് ആണ്. ഒരു സിഗ്നൽസ് ആൻഡ് സിസ്റ്റംസ് പോലെ ഒരു അഡ്വാൻസ്ഡ് സബ്ജക്റ്റ് ഒക്കെ പഠിക്കുമ്പോൾ ഇതൊക്കെ ആവശ്യമാണ്. ലൈക്ക് മാത്തമെറ്റിക്സിൽ കുറച്ചൊക്കെ നമുക്ക് ഒരു കോൺഫിഡൻസ് ഉണ്ടാവണം. ഓക്കെ അല്ലേ? അപ്പോൾ ചെയ്ത് നോക്കണം നമ്മൾ. ഓക്കെ, സോ ഐ എം റൈറ്റിംഗ് ദ വാല്യൂസ്. In case if you are having any problem in identifying a, b and c by using partial fraction expansion, just text me. I will put up one more video how to find the partial fraction expansion. Okay, ഇതിൽ സംശയം ഉണ്ടാവാൻ പാടില്ല. സപ്പോസ് ഉണ്ടെങ്കിൽ പറഞ്ഞാൽ മതി. പാർഷ്യൽ ഫ്രാക്ഷനിൽ ഞാൻ രണ്ട് പ്രോബ്ലം സെപ്പറേറ്റ് ആയിട്ട് എടുക്കാം, വേറെ മാർഗ്ഗമില്ല അതിൽ. ഓക്കെ, ബിക്കോസ് ഇത് വെരി എസെൻഷ്യൽ സ്റ്റെപ്പാണ്. ഓക്കെ, സോ ഹൗ ടു ഫൈൻഡ് ദ വാല്യൂ ഓഫ് എ. I am finding, I mean after doing some steps, I am getting a as 1, b as minus 2, c as 1. This I leave it to you. Okay, so therefore x of z, that particular equation, first equation, right? That particular equation I can write as 1 by z minus 2 divided by z minus 1 by 3 plus 1 by z minus 1, right? Then x of z is equal to 1 minus 2 into z by z minus 1 by 3 plus z by z minus 1. അപ്പോൾ ഇത് pair, z transform pairs. ആൾറെഡി നമുക്ക് ഇത് സിമ്പിൾ പെയർ ആണ്. ആൾറെഡി നമുക്ക് ഇത് ഈക്വേഷൻസ് ഒക്കെ നമുക്ക് അറിയാം. z transform pairs ആയതുകൊണ്ട് ഈസി ആയിട്ട് അറിയാം ആക്ച്വലി. അപ്പോൾ ദിസ് ഇസ് ദ റീസൺ വി ആർ ബ്രേക്കിംഗ് ഇറ്റ് അപ്പ് ആക്ച്വലി. മനസ്സിലായോ? ഈ പാർഷ്യൽ ഫ്രാക്ഷൻ യൂസ് ചെയ്യുന്നത് ഈ ഫാക്ടേഴ്സ് ഒക്കെ നമ്മൾ അതിൽ നിന്ന് ഡിറൈവ് ചെയ്തിട്ട് ഇതിനെ സെപ്പറേറ്റ് ആയിട്ട് ആക്കിയാൽ, ഇതിനെ സെപ്പറേറ്റ് ആയിട്ട് 3 കോമ്പോണന്റ് ആയിട്ട് ആക്കിയാൽ വി ക്യാൻ ഈസിലി യൂസ് ദ z transform pair to write the x of n directly. And that is the reason we are breaking the big equation into actually tiny components, right? So what's my next step? So this is x of z. So I have to find the inverse z transform. That means I have to write x of n. So before writing this, in the previous problem itself I told you one important tip. We have to immediately check the ROC. Otherwise x of n may have something entirely different structure. And in yesterday problem itself I have pointed out clearly, right? So let me check ROC. ROC in this particular question is modulus of z greater than 1. So this will determine, this ROC will determine the structure of x of n. Okay, so let me rub this. So what is ROC here? ROC is modulus of z greater than 1. So we are having the polar coordinates. This is imaginary axis of z domain and this is real axis of z domain. So ഇവിടെ എത്ര പോളാ ഇരിക്കുന്നത്? How many poles are there? So z equal to 0 ഒരു pole, പിന്നെ z equal to 1 by 3. I'm just writing the poles. Hope you are seeing this. Right? അപ്പോൾ ഒരു pole z equal to 1 by 3, then z equal to 1. So 0 here. So and 1 by 3, let us mark it out here. 1 by 3 z equal to 1. assume that this is 1 by 3, this is 1. And what is the region of convergence? Z greater than 1. So that means we are talking about a polar circle whose radius is 1. So what is the region of convergence? Outside. So since the region of convergence is outside the circle, we are talking about positive infinite series. Right? So that means we are talking about u of n here, right? U of minus n, u of n. Okay. So let me go to the next. So let me write it here one more time. X of z is equal to 1 minus 2 z by z minus 1 by 3 plus z by z minus 1. So I can write x of n now because it is a simplified form. This is a complicated equation. I partial fraction use the factors separate location of poles. Okay, separate easy forms. This is easily I can understand. I have lot of Z transform pairs actually. That is the main reason I am using partial fractions to break the equation, to explode the equation into simple forms. Okay, so x of n, inverse Z transform of 1. What is it? Impulse function. So again, either what is it? 1 by 3 a power n u of n. 1 by 3 n u of minus n ano. Last slide the positive series coefficient, positive series. Like the ROC was outside the circle actually. So u of n, u of minus n. Okay. So next one is, this is simply u of n. So this is how we have to find the discrete time sequence when you have been given the Z transform by using partial fraction technique. So what we do by using partial fraction technique? By using the partial fraction technique, we break the big equation into small pieces so that the small piece will be appearing like this actually. These small pieces will resemble some of the Z transform pair so that I can apply inverse Z transform straightforwardly. Just a plug and play system. So now we are going to study one more technique for taking inverse Z transform. This we call it as long division method. Look, sometimes the finding the partial fraction expansion can be trickier actually, can be complicated. So like complicated solution so immediately partial fractions used here we can prefer this one. Otherwise partial fraction method is simple method, very simple method. So let me repeat that in case if you have not understood. Look, my first preference is partial fraction. But if the equation is bit complicated, or else if you feel like you cannot find the partial fraction because it is complicated, then prefer long division method. This is one exam specific mostly use long division method specific find inverse Z transform using partial fraction method. Specific you cannot change that. Okay, so let us try to do this. X of Z is equal to Z by 2Z square minus 3Z plus 1. Here the region of convergence is this one, modulus of Z lesser than 1 by 2. They have asked you to use long division method, right? So how to do this? Keep it in mind. What is x of Z? X of Z I can write like minus infinity to infinity. X of n is Z power minus. Extremely important point. And then I expand how it will be looking like. So there will be a origin, a component at the origin. So negative side value x of minus 1 into Z power plus 1. Okay, let me write this. And this summation goes on. This is plus 1. At the same time, positive side x of 1 is a power minus 1. It's very, very critical, very important information. Keep that in mind. Okay. Left side is another positive, right side is another powers. Powers negative actually. Keep this in mind while solving the problem. So this equation has how many poles? You will factorize it. You will be having two poles. One is z equal to 1 by 2 and z equal to 1. I ask you to find this one. Okay. So, this is correct. That message. Let me correct that. Okay. But I suggest you to do this. This step mistake exam mark. So, please do it. Okay. According to the question, ROC have been given like this. It's lesser than 1 by 2. പക്ഷേ നമ്മളിപ്പോൾ ശ്രദ്ധിച്ചു ഈ ക്വസ്റ്റ്യനിൽ നിന്ന് പോൾസ് വേറെ ഒരു ഇൻഫർമേഷൻ നമ്മൾ എടുത്തു, ദാറ്റ് ഈസ് എ ലൊക്കേഷൻ ഓഫ് പോൾസ്. അപ്പോൾ രണ്ട് ഇൻഫർമേഷൻ നമുക്ക് കിട്ടി, രണ്ടും ക്രിട്ടിക്കൽ ഇൻഫർമേഷൻ ആണ്. ഒന്ന് ROC, മറ്റൊന്ന് ലൊക്കേഷൻ ഓഫ് ദ പോൾസ്. രണ്ട് ക്രിട്ടിക്കൽ ഇൻഫർമേഷൻ നമുക്ക് കിട്ടിയിട്ടുണ്ട് ഇപ്പോൾ. ഓക്കെ അല്ലേ? സോ ROC വിൽ ബി ലുക്കിംഗ് ലൈക്ക് ദിസ്, റൈറ്റ്? ലെസർ ദാൻ 1 by 2 മീൻസ് സംതിങ് ലൈക്ക് ദിസ്. ഇത് 1 by 2. അപ്പോൾ സർക്കിളിൻ്റെ ഇൻസൈഡ് ആണ്. സോ വി ആർ ടോക്കിംഗ് അബൌട്ട് നെഗറ്റീവ് series ആണ്, നെഗറ്റീവ് ആക്ച്വൽ ടൈം സീരീസ് ആണ്. വി ആർ ടോക്കിംഗ് അബൌട്ട് നെഗറ്റീവ് ടൈം സീരീസ്, റൈറ്റ്? നെഗറ്റീവ് ടൈം സീക്വൻസ് എന്ന് പറയാം, സീരീസ് എന്നും പറയാം. സോ വി ഹാവ് ടു കെയർഫുള്ളി നെഗോഷിയേറ്റ് ദിസ് പർട്ടിക്കുലർ സ്റ്റെപ്പ്. എക്സ്ട്രീംലി ഇമ്പോർട്ടൻറ്റ് സ്റ്റെപ്പ്. ബിക്കോസ് ഈ പ്രോബ്ലം ചെയ്യുമ്പോൾ നിങ്ങൾക്ക് മനസ്സിലാവും ഇതിൻ്റെ വലുപ്പം. ലൈക്ക് ഇത് നെഗറ്റീവ് ആണോ പോസിറ്റീവ് ആണോ? ഞാൻ കഴിഞ്ഞ പ്രാവശ്യം കാണിച്ചു തന്നായിരുന്നു. യു ഓഫ് എന്നിൻ്റെ സ്ട്രക്ചർ തന്നെ മാറിപ്പോയി. അതുപോലെ തന്നെ ഇവിടെയും ശ്രദ്ധിക്കണം, മാറിപ്പോയാൽ മൊത്തം പോയി. ഓക്കെ, ഈ പർട്ടിക്കുലർ സ്റ്റെപ്പ് വളരെ വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. ഓക്കെ, സോ ലെറ്റ് മീ റബ് ദിസ് ടു സ്റ്റാർട്ട്, or else we can go to the next slide. Okay, so keep it in mind, this is negative time series. Okay, so this question engane z divided by 2z square minus 3z plus 1. So from the characteristics of the ROC and the location of the poles, I found this as negative time sequence. So if it is a negative time sequence, write this equation like this. Idundallo, idu ingane eludum, like it should, I mean the powers should increase as you write. Same ആണ്, but I am not writing like this. 2z square minus 3z plus 1 ഇങ്ങനല്ല എഴുതിയത്, ഇങ്ങനെയാണ് എഴുതിയത്. അതിൻ്റെ റീസൺ അടുത്ത പ്രോബ്ലം ചെയ്യുമ്പോൾ ക്ലിയർ ആയിട്ട് ഞാൻ പറഞ്ഞു തരാം. Okay, now you can actually just do like this. Long division method, and what I am doing is I am going to divide this numerator by this particular denominator. But how I am going to write? I am going to write like this because it's a negative time series. This is the major reason. Negative time series I am writing like this. The powers are increasing as I go by. Okay, so this by z. Okay, so how to do this particular problem? I have to, I mean just a long division you already cheyirukonu, numerical long division same on. Appo into z, this particular coefficient I am putting it as z. 1 into z is z minus 3z square plus 2z cube. Agreed? So subtraction will yield me 3z square minus 2z cube, right? So what is the next one? Next, multiple 3z square, about 3z square. Okay, so this multiplication will yield me 3z square. That means this one as well as a whole term will yield me 3z square minus 9z cube plus 6z power 4. Again the value will be subtraction. 7z cube minus 6z power 4. What about this one? 7z cube. So 7z cube minus, I hope you understand this one. Okay, phone 21z power 4 plus 14z power 5. Again what will come? This is subtraction. So what I will be getting is 15z power 4, something like this, and it goes on. Okay, this is 15. So next term work it will be 15z power 4 plus goes on. So somehow I have divided this and I have obtained the coefficient like this. So let me write the coefficient separately. X of z, because it's a, I mean, numerous constants will be there, so I am just denoting it as a dot there, plus 15z power 4 plus 7z power 3. I hope you know why I am writing this, because a summation in the structure x of z power minus n. So that is the reason this is a descending now. 7z cube plus 3z square plus z. This order right thanne ezhudanam. 4 this 3. I hope you see this. This order right thanne ezhudanam. Ezhuthi illengil pani kittum. Okay, like this is z. So from this, what are the coefficients now? These are all the coefficients, right? Agreed? This is 1. These are all the coefficients. So finally, x of n can be simply written like this one: 15, 7, 3, 1, 0. So 0, 1. Yes, because this is z power 1 alle. So adutha component there is 0 undu ivide. Okay, that is origin. Fine. Which is origin here? Which is origin here? Since I have found out that the time sequence is a negative time sequence. Very sure my origin is this one, right? So this is how to solve this particular problem. So let's try to do one more problem so that you can understand more. Okay, x of z is equal to z by, same question, 2z square minus 3z plus 1. Same question, but same question illa. Because ROC is different. I told you, ROC plays a critical role. So this particular case, modulus of z is greater than 1. So as you know, this is one important information. Rendamtha critical information, location of poles. So poles in parayanathu z equal to 1 by 2, z equal to 1. Okay, so this will yield me, say this is 1, ROC is something like this. That means I am talking about, a signal which exists outside the circle. Well, that means I am talking about positive sequences, positive time series. So that is the reason I am going to write the long division method like this actually: 2z square minus 3z plus 1. If it is a negative series coefficient, how I will write? 1 minus 3z plus 2z square. The reason ippadiyum paranthuram. The reason ningal thanne manasilakkum. Okay, what will be getting? Half times z power minus 1. Shradhichadu. Positive time series ആണ്. അപ്പോൾ എനിക്ക് correct ആയിട്ട് positive time series means z transform expand ചെയ്യുമ്പോൾ എനിക്ക് കിട്ടുന്നത് x of 1 into z power minus 1. അപ്പോൾ നെഗറ്റീവ് പവേഴ്സ് ആണ് വരുന്നത്. ഞാൻ കഴിഞ്ഞ സ്ലൈഡിൽ കാണിച്ചായിരുന്നു അല്ലേ? അപ്പോൾ കറക്റ്റ് ആയിട്ട് വന്നു. നെഗറ്റീവ് പവേഴ്സ് വന്നു. നെഗറ്റീവ് പവേഴ്സ് വന്നു. അപ്പോൾ ഇത് ഇങ്ങനെ തന്നെ എഴുതണം. മാറ്റി എഴുതിയാൽ നെഗറ്റീവ് ടൈം സീരീസ് ആയി പോകും. ഇത് പോസിറ്റീവ് ടൈം സീരീസ് ആണ്. പോസിറ്റീവ് ടൈം സീരീസ് ആയതുകൊണ്ട് ഈ സ്ട്രക്ചർ ഇങ്ങനെ തന്നെ എഴുതണം. This particular step is extremely important, otherwise you will be missing the result actually, right? So let me rub this. Z minus 3 by 2 plus half into z power minus 1. Okay, about next, what is the next one? 3 by 4 z power minus 2, because then only, wait, 3 by 4 z power minus 2, then only if I multiply this will be vanishing, right? So that is the reason I am multiplying this one by 3 by 4 z power minus 2, right? So what I will be getting? 3 by 2 minus 9 by 4 z inverse plus 3 by 4 z power minus 2. What will be getting? This one subtraction, this one will vanish out. So this is like 7 by 4 z power minus 1 minus 3 by 4 z power minus 2, right? And these steps will go on. Okay, so I am writing directly here. So you have to complete this. Okay, at least 4 terms I need, at least 4 terms. Okay, so since you know how to do, I am writing the stuff directly here. X of n is equal to 0 comma 1 by 2 coefficient 1 by 2 comma 3 by 4, this one, I hope you see this one, 3 by 4 comma 7 by 8 and so on, right, and so on. So this is x of n now. What is the origin here? Origin is this one. Okay, so this is how to do this particular problem. So very obviously you will be having a doubt now whether the same problem, if I solve by using partial fraction expansion, will I get the same answer? Am I right? So that is your homework today. Okay, so use the same problem, that is, what is it? X of z is equal to z by 2z square minus 3z plus 1 ROC lesser than 1 by 2 ROC greater than 1. Do these 2 problems and submit it as assignments, right? So you have to submit it as homeworks, and by using the partial fraction expansion series, right? Okay, thank you very much.